reveal cards in increasing order. Let's first try to understand the problem. The problem is that we are just giving a random array. So for example, we are giving this kind of a random array, and we want to reorder it. We can reorder it in any order we like, but the final result of the sequence of the card would be in increasing order if we do the following steps. So for example, we're gonna check this answer. So what's gonna happen? Let's first check the answer. So we have this kind of answer, and then we're gonna take one card and put this card. So for example, we're gonna simulate it like this. We're gonna take this card 2 and put 13. Take the top card, reveal it, and take it out of the deck. And then if there are still cards in the deck, then put the next top card of the deck at the bottom of the deck. So this means, first of all, we're gonna take one card, and then we're gonna take this 13 at the bottom of the deck. So this is the bottom of the deck. Now we're gonna take this 3, and we're gonna take 11 at the bottom of the deck. So this is 11, and then we're gonna take 5, and we're gonna put 17 at the bottom of the deck, and then we're gonna take 7. So this is our first simulation, and then we're gonna do the following step. As you can see, the third one, if there are still unrevealed cards, go back to step 1, otherwise top. So we're gonna simulate it for the next step. So for the next one, what do we have? We have this one. So we have 13, 11, and 17, and this is our result array. So inside the result array, we're gonna take 13 and put 11 out of it, and then we're gonna take 17. So inside it's gonna be 13, 17, and let me check if there's something wrong with it. So for the first step, we're gonna take 2, 3, 5, and 7. So this is left behind. So we're gonna put it then put the next top card of the deck at the bottom of the stack. So we put it at the bottom. So this is bottom, so this is bottom. So this means the 17 is the top, right? So 17, 11, and 13. So this gonna be the sequence. I got quite confused. Let's check the example maybe. So first of all, we're gonna take the top card of the stack, and if there are still cards in the stack, then put the next top card of the stack at the bottom of the stack. So let's try this example from here. So we're gonna try 2, 3, 5, and 7, and then we're gonna put 13 at the bottom, and 11 at the bottom, and 17 at the bottom. This means 13 at the top. Now we're gonna try the same step. We're gonna take I got quite confused. Let me check. Where 2 is at the top of the stack. Let's just try this example maybe. It's gonna be easier. So we're gonna take 2 and move 13 to the bottom. So it's gonna be like this. So we're gonna take out 2, so 13 at the bottom. Next we're gonna take 3, so 11 would be at the bottom. and next we take 5, so 17 would be at the bottom, and next we take 7, so 13 would be at the bottom. Yeah. Now from here we can take 11, so 17 would be at the bottom. Yeah, if we take 11, so 17 would be at the bottom. Now we have 13, we take 13, so the 17 would still be at the bottom. We only have 17, and next we're gonna take 17. Yeah, so this gonna be the whole step. Yeah, I don't know what mistake I made, but let's check it. So after I take 2, 3, 5, and 17, what I left behind, it should be 11, 17, and 13. Yeah, so if I take 2, I'm gonna put 13 at the bottom, and then I take 3, so 11 should be at the bottom. Yeah, and then 17 should be at the bottom. Yeah, so up to here it is right. Now I want to take 7, because if I the 7 is still, so if I take 2, 3, 5, so the 7 is still outside. Yeah. Now I want to take 7. If I take 7, so 2, 3, 5, 7, so the 13 would be at the bottom. So inside it's gonna be 11, 17, and 13. Yeah. Now I want to take the next one. I want to take 11 and 17 would be at the bottom. Yeah, so let me just copy. Yeah, so if I take 11, so 17 would be at the bottom. Yeah, so this is the whole simulation. So we have to simulate like this, otherwise we cannot find the pattern. Yeah. So here we have 11. Next we're gonna take 13. So there's only 17 left behind. So the final step we're gonna take this 17. Yeah. Yeah, so this is the simulation of the step. Now we want to find this kind of result, but we can reorder this stack in any order. Yeah, it seems a difficult problem, but we can try to solve it like this. We can try to first find the smallest number inside the deck, or the biggest number inside the deck, and then we're gonna build a sequence like the result. Yeah. So how can we do that? First of all, we're gonna sort the array, because after sorting we can always find the biggest number, but we're gonna sort it in reverse order. So it's gonna be 17, 13, 11, and 7, 5, 3, 2. And then we're gonna try the biggest number. So if we sort it like this, so the first step is that we're gonna try to find the first number. The first number is 17, right? So this is our result. If there's only one card, it is okay. So what about there are two cards with 17 and 13? What are we gonna do? Yeah, because we're gonna make it in, yeah, so after the simulation, we're gonna make it in increasing order. So if there are two cards, the next card must be smaller than all my previous cards. So I must take this 13 first. Yeah. So what left behind is that we cannot see any pattern at the moment. So, but this 17 must after this 13 definitely, because if we find a smaller number, this small number must be the first place. So if there are two cards, this 17 must after this is 13, so we put it here. So this means if there are only two cards, the simulation is okay. We're gonna take 13 and 17. So now we're gonna check if there are three cards, what's gonna happen? Definitely we're gonna choose 11 at the moment. Yeah, but we need to plus some others. But we cannot plus 13 and 17 directly, because this is not right. If we plus it, we're gonna take 17 first, but we have to take 13 first. But how can we make it, how can we prepare we're gonna take 13 first. We have to prepare some other numbers that is not in priority of 13. Yeah. So what about other numbers? So it must be this 17, because 17 should always be after this 13 while we're taking the card. Yeah. So what we can do, we're gonna take the last card at the top of this stack, and then it's gonna be the result. Yeah. So we're gonna take 17 and 13. So our result is 11, 17, and 13. It seems okay if there are only 3 cards. So what about we add more card? So what about we add another card, maybe 7? So if we were to put 7 inside the deck, what we can do? The 7 must be the first place because it must be the smallest number. And then we're gonna plus something. Yeah. So the next card, if we were to take the card, the next card must be like 11 and 13. But currently we cannot put it there. Yeah, because the next priority is 17. We have to put some other card in before this is 17. So what about the other card? So it must be this 13. Yeah, because this 11, this 17 must be after this 13. So this is why, by greedy idea, this 13 must be before this 11. Only in this way we can make the right sequence in increasing order, because 13 has the priority more than this 17, and 11 has the priority more than 13. So it's gonna be like this. So yeah, it's gonna be 13 first, because next step we're gonna choose 11. Yeah, but this 13 have a priority more than this 17. So 17 should be last. Yeah. So what about the step? It means we take the last number of the stack, put it on the top, and then we're gonna plus the smallest number, gonna plus the result. It's gonna be like this. So we're gonna put it inside. Yeah. Now we find some patterns of how to solve the problem. Yeah. Now let me finish this simulation of all the numbers. So what about we were to add another number, maybe 5. So what are we gonna do? So we're gonna use a 5, and we're gonna take the last number first. Yeah. So let me copy it. So we're gonna take the last number first, and here gonna be yeah, let me check if I did something wrong. So we're gonna take this last number first here, just after this 5. So this is our result if we have another number. So as you can see, the sequence of 5, 7, 11, it should be okay. Yeah. Now we're gonna finish all other simulations. So for the next step, so currently we have these numbers. Yeah. So for the next step, if we have like number 3, so we're gonna take this number 3, and we're gonna take out the last number and put it after 3. So this is our result. Yeah. Now we're gonna add this number 2. Let's put 2 inside to check what's gonna happen. So if we were to put 2 inside, so here is 2. So we're gonna take the last number out and put it after 2, and yeah, this is the final result. As you can see, the final result is 2, 13, 3, 11, 5, 17, and 7. So it should be right. So this is the greedy idea. We're gonna check always which one is in priority. Yeah. So if we find the next number, the smallest number must be in priority. So we put it first, and then we're gonna choose all other numbers. Yeah. So for example, the next number must be 3 in priority, but we have to put another number just in between these 2 and 3, and then we can keep the sequence to do the simulation in increasing order. Yeah. Now let's try to solve the problem. So first of all, we're gonna sort the deck. So we're gonna sort it in reverse order, and then we're gonna check the numbers one by one. So for I card, enumerate the deck. Yeah, we're gonna check this I. If I equal to 0, it means the first card. So result should append the card. Yeah. So I'm gonna prepare a result array. It should be empty. Now, else. So we're gonna do the simulation. result should be equal to the first number, that is the card, right? Because the card must be the smallest up to now. So the card should plus the last number inside the DAC. So it's gonna be DAC minus 1. Yeah. And then we're gonna plus the left. So it's gonna be DAC from 0 to minus 1. Yeah, so this means we're gonna take the last one. For example, this is 13. We're gonna take the last one, and then we're gonna take this 11 and 17. So it's gonna be like this. So finally, we just need to return the result. I think the difficult part is about that. Normally, this kind of problem we should. Yeah, let me check what is wrong. Yeah, I have more numbers. It is unexpected. Yeah, let me just have a check of what is wrong with it. Yeah, I have more numbers than I expected. Yeah, here we cannot append a card. We just need to use the result should be equal to this. Yeah, result should be equal to my current card. I think it should be like this. No. This is not DAC. This is a result. Yeah. Yeah. So here I can use append, and here it is not the DAC anymore. It is the result array. Yeah, I simulated this is the result array, not the DAC. Yeah. Now you can see it is okay. Yeah. So this is the. Yeah, I think this is a better way of solving such kind of problem. We have to simulate it. After that, we find some patterns, and then we're gonna do it according to the patterns. Now let's analyze the time complexity. So this is O(n), a for loop, and this DAC's sort is n log n. Yeah. And for here, so for the result array, so we're gonna separate it into different parts and plus them together. So this is another O(n). So the time complexity is n squared, because n squared is more than n log n. So let's check. So n is 1000. It should be okay for this problem. Thank you for watching. See you next time.